Tonight, we're going to spend some quiet time with the most haunting idea in modern astronomy. The idea that the universe should be full of voices, and is not. The math says billions. The sky says nothing. In this video, we will walk through the moment a physicist asked a question at lunch and changed the field forever. We will look at the equation that predicts a galaxy full of civilizations. We will examine the silence we have actually measured across 1,300 nearby stars with the most sensitive instruments ever built. We will walk slowly through 8 proposed answers, the ones that comfort, the ones that disturb, and the ones that astronomers do not like to discuss after dark. And we will end with the answer that may be the hardest of all. By the end of tonight, you will see why every solution to the Fermi paradox is more disturbing than the one before it, and why the silence itself may be telling us something we have not wanted to hear. So settle in wherever you are tonight. Let your shoulders drop. Pull a blanket over yourself. Let the room go quiet. Let your phone go dark. We are going to take our time with this, because this question deserves time. If you have been enjoying these long, slow nights, subscribing helps me keep making them, and I genuinely appreciate everyone who stays for the full walk. Now, let us begin. The story is one of those stories that has been told so many times, in so many slightly different versions, that the edges have softened. But the heart of it has stayed the same for 75 years. The year is 1950. The place is the cafeteria at Los Alamos National Laboratory in New Mexico, the same lab where the first nuclear weapons were designed during the war, now repurposed for the strange new science of the post-war atomic age. For physicists are sitting at a lunch table. One of them is Enrico Fermi, the Italian-born scientist who had built the first nuclear reactor under a squash court in Chicago, and who was, by all accounts, one of the sharpest minds of the 20th century. The conversation, as best as anyone can reconstruct it, had wandered. They had been talking about a recent magazine cartoon showing flying saucers. They had been talking about faster-than-light travel and whether it might one day be possible. They had been talking about the strange sightings reported in the news that summer, the way people had been talking about flying objects for years. And then, in the middle of the conversation, Fermi went quiet for a moment. He did some quick calculations on a napkin, the way he was famous for doing. And then, in the casual tone of a man asking where the salt was, he asked a question. "Where is everybody?" He said it casually. Nobody has answered him since. That was the moment. That is, as far as anyone can tell, the moment the question entered the world. 3 words spoken over lunch. The men at the table laughed at first, because Fermi often said funny things, and because the question seemed almost too obvious to be serious. But Fermi was not joking. He had run a quick estimate in his head, the kind of estimate he was famous for, and the numbers had told him something the sky was not. The numbers said the galaxy should be full of voices. The sky said the galaxy was empty. You can imagine the small moment of silence at the table when the man understood that he meant it. The afternoon light coming through the cafeteria windows. The clinking of cutlery somewhere in the room. The quiet realization that one of the most important questions in science had just been asked over lunch, in a single sentence, and that nobody had a good answer. 75 years later, we still do not have a good answer. The question has only deepened. The sky has only become quieter. And the more carefully we have listened, the stranger the silence has become. That is where we are going tonight. To understand why Fermi's question is a paradox at all, you have to understand why scientists ever expected the sky to be loud in the first place. The expectation comes from the numbers. And the numbers, when you let them sit for a while, are difficult to argue with. Start with our galaxy. The Milky Way is one of perhaps 2 trillion galaxies in the observable universe, a barred spiral about 100,000 light-years across, with our Sun sitting on a quiet inner edge of the Orion Arm, about 27,000 light-years from the galactic center. Inside this galaxy, astronomers estimate there are somewhere between 100 billion and 400 billion stars. The exact number depends on how you count the smallest, dimmest red dwarfs, which are difficult to see even when they are nearby. The lower estimate is the more conservative one. The higher estimate may be the more accurate one. Either way, the number is staggering. 100 billion stars in our galaxy alone. And we now know, thanks to the Kepler Space Telescope and the missions that followed it, that essentially every star you can see in the night sky probably has at least one planet, and most of them have several. NASA estimated, based on Kepler data published in 2013, that there could be as many as 40 billion Earth-sized planets sitting in the habitable zones of their stars within the Milky Way alone. 40 billion potentially habitable worlds, just in our galaxy. Now multiply by the number of galaxies. 2 trillion. The total number of potentially habitable planets in the observable universe is estimated, in the most carefully published Bayesian work, at around 10 to the 22nd power. That is a 1 followed by 22 zeros. It is a number so large that the human brain cannot meaningfully hold it. It is more habitable planets than there are grains of sand on every beach on Earth, multiplied many times over. And yet the sky says nothing. In 1961, an American astronomer named Frank Drake tried to make this strange tension precise. He was preparing for a small scientific meeting at the National Radio Astronomy Observatory in Green Bank, West Virginia, the first scientific gathering ever convened to discuss the search for extraterrestrial intelligence. To organize the agenda, he wrote down a simple formula on a chalkboard. The formula tried to estimate in 7 steps how many communicating civilizations should currently exist in the Milky Way alone. The formula starts with the rate at which new stars form in our galaxy. Then it asks what fraction of those stars have planets. Then what fraction of those planets are habitable. Then what fraction develop life. Then what fraction of life-bearing worlds develop intelligence. Then what fraction of intelligent species develop the ability to broadcast signals into space. And finally, how long, on average, those broadcasting civilizations last before they go quiet. The astronomer Jill Tarter, who spent her career searching the sky, once said the Drake equation is not really a calculation. It is a way to organize our ignorance. Each factor is a question we cannot fully answer. But even if you plug in conservative numbers, even if you assume that life is rare and intelligence is rarer and civilizations do not last long, the equation almost always returns a number greater than 1. Some versions return numbers in the thousands, some in the millions. The galaxy, by the math, should be loud. And yet, when we point our largest radio telescopes at the sky and listen, we hear nothing but the quiet hiss of cosmic background radiation, the residual heat of the Big Bang, and the occasional radio signal from a pulsar or a distant quasar. We do not hear voices. We do not hear engineering. We do not hear anything that looks like another civilization saying hello. That is the paradox. A galaxy that should be full of voices, and a sky that has not said a single thing. The question now is what to do with that silence. And the answers, as we will see, do not get any easier. The first time anyone seriously listened was in the spring of 1960, in the same observatory where Frank Drake would later write his equation. The project had a name borrowed from the Wizard of Oz books, a hopeful, almost playful name for the first scientific search for intelligent voices beyond Earth. They called it Project Ozma. The setup was simple, in the way the first attempts at any new science are always simple. Drake pointed an 85-foot radio telescope at 2 nearby sun-like stars, Tau Ceti and Epsilon Eridani, both within 12 light-years of Earth. He tuned the receiver to a frequency near the natural emission line of hydrogen, the most common element in the universe, on the theory that any civilization trying to be heard might broadcast on a frequency that other scientists would naturally point their instruments at. Then he listened. For about 200 hours over the course of several months, Drake and his small team sat in control room at Green Bank and watched a strip chart recorder draw a thin black line across rolling paper. The line traced the radio noise coming from the 2 stars. They were waiting for a deviation, a spike, anything that did not look like background hiss, anything that looked like it had been engineered. They got one false alarm, a strong signal that turned out to be a passing aircraft. Apart from that, the line stayed flat. But the era that followed was hopeful in a way it has been hard to recover since. Through the 1960s and 1970s, scientists believed that finding another civilization was a matter of time. They were optimistic. The Drake equation was new. The first exoplanets had not been found yet, but everyone assumed they were out there. Carl Sagan was on television. The Voyager spacecraft were launched in 1977 with golden records bolted to their hulls, in case anyone, anywhere, ever found them. There was a feeling, in those years, that the silence was about to end. They expected an answer. They got a hum. The hum has continued for 65 years. Each generation of astronomers has gone into the field expecting to be the one that finds the signal. Each generation has come out, decades later, with no signal to show. The instruments have gotten better. The data pipelines have gotten faster. The number of stars surveyed has gone from 2 to many thousands. And the answer has stayed the same. Nothing. This is the strange thing about the Fermi paradox that does not always come through in the popular versions of the story. The paradox is not a thought experiment. It is a measurement. We have actually pointed the most sensitive instruments humans have ever built at the sky for decades. And the silence we're talking about is the silence we have actually recorded. The next part of the story is what those modern instruments have heard. In 2015, the Russian-Israeli investor Yuri Milner stood on a stage at the Royal Society in London, alongside Stephen Hawking and a small group of astronomers, and announced a $100 million, 10-year initiative to do, in the modern era, what Frank Drake had started with Project Ozma. They called it Breakthrough Listen. The scale was different this time. Project Ozma had pointed a single telescope at 2 stars for 200 hours. Breakthrough Listen, by 2025, has used the largest radio telescopes in the world, including the 100-meter Robert C. Byrd Green Bank Telescope in West Virginia and the Parkes Telescope in Australia, to survey thousands of nearby stars, hundreds of nearby galaxies, the galactic center itself, and a number of unusual objects in the sky that scientists wanted a closer look at. By any reasonable measure, this has been the most thorough techno-signature search ever conducted. The receivers cover frequencies from about 1 GHz to 11 GHz, the same range where any naturally arising civilization might be expected to broadcast. The data pipelines can sift through billions of frequency channels at once, looking for the kind of narrow, drifting signal that would suggest a transmitter on a planet rather than a natural source. And here is what they have found. In one major published survey, Breakthrough Listen examined 1,327 nearby stars in the frequency range from 1.1 to 3.45 GHz. The result, after careful analysis and removal of human-caused interference, was a null result. No detected techno-signatures. The survey did not find evidence of advanced transmitters around any of those 1,300 stars. In another survey, the project examined 61 transiting exoplanet candidates discovered by NASA's TESS mission, the kind of stars where any civilization on a transiting planet would naturally know we exist because they could see Earth crossing in front of our sun the same way we see their planets crossing theirs. That survey also returned a null result. In yet another survey, the team looked at the restricted Earth transit zone within 150 parsecs of the sun, a narrow band where any planet would have a geometric line of sight to detect us. Of 111 targets, they found one candidate signal on a star called HIP 109656, which on follow-up turned out to be consistent with terrestrial radio interference. Another null result. The pattern is consistent. The deepest, most sensitive search for intelligent voices in the history of human science has been listening for 10 years across the most likely targets in the sky. And what it has found is the deepest silence ever measured. And it is worth pausing on what these null results actually mean, because the word null can sound thin in writing, and the meaning is not thin at all. When a survey returns a null result, it does not mean the instruments were not sensitive enough. It means that any narrowband transmitter sitting on a planet around any of those stars, at the kinds of power levels we know are physically possible, would have been detected. The Breakthrough Listen team can place hard upper limits. Fewer than 15% of the stars in some surveys can be transmitting at the kind of power our own military radars use. Fewer than a small fraction can be running anything substantially more powerful. The silence is not a gap in our knowledge. It is a measurement of how empty the radio sky is, to a precision that would have astonished Frank Drake in 1960. That is the data, and every answer to the silence makes the silence louder. The numbers say there should be voices. The sky says there are none. And so we are forced into the next part of the question, the part Fermi could not have known would be ours to face. If they should be there and they are not, then where are they? The proposed answers are what the rest of this video is about. We will walk through 8 of them, in order from the gentlest to the hardest. Each one solves the paradox. Each one is more disturbing than the one before it. And by the time we reach the last solution, you will understand why scientists who study this question often go quiet when they are asked about it after the cameras turn off. The first proposed answer is the gentlest one. It is the one most astronomers would prefer to be true, because if it is true, the universe is not hostile, just young. The argument goes like this. The universe is about 13.8 billion years old. The first stars formed only a few 100 million years after the Big Bang, but those first stars were enormous, short-lived, and made almost entirely of hydrogen and helium. They could not have hosted habitable planets, because the heavier elements that life needs, the carbon and oxygen and iron, were only forged in the deaths of those first stars. It took several generations of stars dying and reforming before the universe had enough heavy elements scattered through space for rocky planets like Earth to form at all. By that measure, the Earth is not a latecomer. The Earth, at 4.5 billion years old, is closer to being one of the first habitable planets in the universe than one of the last. The conditions for technological civilization may have only become possible in the last few billion years. And evolution, the slow process by which simple life becomes complex life, and complex life eventually develops curiosity, takes a long time. If that is true, then the silence we're listening to is not the silence of an empty galaxy. It is the silence of a galaxy where almost no one has had time to evolve yet. We are not late. We are early. There is even a version of this argument that suggests we may be the first technological civilization in our part of the galaxy. Not the first life, not the first intelligent life, but the first to develop radio technology, the first to point telescopes at the sky, the first to be capable of being heard. The other voices are coming. They just are not here yet. This is the gentlest answer because it does not require any tragedy. It does not require civilizations to be rare or to die. It just requires the universe to be young and life to be slow. We are alone tonight because we got here first. But sit with the implication for a moment. If we are the first, we are also the example. The first civilization to develop the ability to destroy itself with nuclear weapons. The first to begin restructuring its own atmosphere. The first to look at its own history and ask whether it will survive the next few centuries. If we are the first, we are also the test case. The galaxy is watching, in some sense, to see whether the first civilization makes it through. And there is something quietly heavy in that thought, that the silence is not because we have failed to listen. It is because there is, so far, nothing yet to hear. Lonely is not the worst thing the universe can be. But the next answer suggests that maybe loneliness is just luck running out. The second proposed answer was put forward most fully in a book published in the year 2000 by the paleontologist Peter Ward and the astronomer Donald Brownlee. The book was called Rare Earth, and the argument was that almost everything astronomers had been assuming about the conditions for life was too generous. The argument starts with the basic chemistry. Yes, the universe has the right elements for life. Yes, there are billions of habitable zone planets in the galaxy. But Ward and Brownlee argued, a habitable zone is not the same thing as a habitable planet. The conditions that allowed complex life to develop on Earth are not just unusual. They are stacked layer upon layer, in a way that most planets in the galaxy probably cannot match. Consider, they said, the things Earth has that other worlds may not. A large moon, formed by a giant impact early in our planet's history, that stabilizes the tilt of our axis and prevents catastrophic climate swings. A magnetic field generated by a liquid iron core, which deflects the worst of the solar wind and prevents our atmosphere from being slowly stripped away the way Mars's was. A position in the galaxy that is far enough from the dense, high-radiation core that life is not constantly sterilized by nearby supernovae, but close enough that there are enough heavy elements to build rocky planets in the first place. A solar system architecture that has Jupiter in just the right place to deflect most incoming comets and asteroids, but not so close that it disrupts the inner planets. Plate tectonics, which recycles carbon and regulates the climate over geological timescales. A long, stable star, neither too large to burn out quickly nor too small to bathe its planets in stellar flares. And, perhaps most importantly, a long stretch of time without an extinction-level catastrophe. The dinosaurs went extinct 66 million years ago. Before that, the Permian extinction wiped out 90% of marine species. There have been at least 5 major mass extinctions on this planet, and any one of them, if it had been only slightly worse, could have ended the lineage that eventually led to us. Stack all those conditions together, multiply the probabilities, and the result is sobering. Earth is not just a habitable planet. Earth is a habitable planet that won a long sequence of cosmic lotteries, one after another, for 4.5 billion years. If Ward and Brownlee are right, then there may be plenty of life in the universe, but most of it is microbial, sitting in subsurface oceans on cold moons, going nowhere because the conditions for complex multicellular life never aligned. The galaxy may be teeming with bacteria. It may also be almost entirely silent, because the conditions to develop something more never happened more than once. This is colder than the first answer. The first answer said the silence is temporary, just early. The second answer says the silence is permanent, just rare. We are alone not because we got here first, but because the conditions for civilizations are so improbable that they almost never occur in the same place at the same time. And here is where the dread starts to deepen. Because if Earth is rare, then everything we have ever made, every poem, every conversation, every shared meal, every quiet evening like this one, is sitting on top of a planetary configuration that may not exist anywhere else for thousands of light years in any direction. The silence becomes precious in a way that is also frightening. Maybe the silence is just luck running out. The third proposed answer is older than it sounds. It was put forward in 1973 by the radio astronomer John Ball in a paper that came out of MIT, and it has stayed in the conversation ever since because it cannot be entirely ruled out. The hypothesis is called the zoo hypothesis. The idea is simple and disquieting in a different way than the previous answers. What if they are out there, and they have decided not to make contact? The argument runs something like this. Imagine that civilizations capable of interstellar communication, or even interstellar travel, are not rare at all. Imagine the galaxy is, in fact, populated by older civilizations that have been around for millions of years longer than we have. They would have noticed Earth long ago. They would have seen our biosphere change as oxygen filled the atmosphere 2 billion years ago. They would have seen our radio noise begin to leak into space about 100 years ago. They know we are here, but they have not contacted us. And in the zoo hypothesis, the reason is policy. A sufficiently mature civilization, the argument goes, would understand that contact with a younger civilization disrupts the younger civilization's natural development. They would have seen this play out before. The way developed nations on Earth sometimes encountered isolated peoples and accidentally destroyed them with disease, with culture shock, with the simple weight of unfamiliar technology. A wise interstellar community might agree, perhaps unanimously, perhaps as a basic ethical principle of cosmic citizenship, to leave young civilizations alone until they are ready. The Earth, in this picture, is a nature preserve, or a quarantine, or a kindergarten with a one-way mirror. The voices are out there in their billions, but the rule is silence until graduation. This sounds, when you first hear it, almost gentle. The voices exist. We are not alone. We are simply not allowed, and yet there is something comforting about it. The same way there is something comforting in the idea of a guardian. But the zoo hypothesis is harder to live with the longer you sit with it. Because if it is true, it means we are being watched. Right now, tonight, the Earth has been observed, perhaps for billions of years, by intelligences whose patience is so deep we cannot imagine it. They have watched our oceans freeze and unfreeze. They have watched our continents drift. They have watched the rise and fall of dinosaurs and the slow emergence of our ancestors from the African plains. They have watched humans build pyramids and cathedrals and skyscrapers, and they have not interfered, even when we destroyed each other in wars, even when we approached the brink of nuclear annihilation. That is a profound restraint. It is also a profound surveillance, and it raises a question that the zoo hypothesis cannot really answer. What is the criterion for graduation? What does the silence end at? What would we have to do, or fail to do, for the rule to lift? And do we want to know? There is a deeper, more troubling version of the zoo hypothesis as well. It is sometimes called the interdict hypothesis. In this version, the silence is not a kindness. It is a containment. We are not being protected. We are being kept in. And the moment we develop the technology to leave the solar system, the silence may not stay silent for long. If they are watching, they have been watching a long time. And the next answer suggests they are watching for a reason. We are now at the fourth proposed answer. And this is the one that scientists who specialize in this field tend to talk about more than any other, because it is the one that has the most analytical force. It comes from a 1998 essay by an economist and futurist named Robin Hanson, who was at George Mason University at the time. The essay is called The Great Filter. Are we almost past it? The phrase great filter has been part of the conversation ever since. The argument is mathematical, but the heart of it is simple. If we look at the path from non-life to a civilization that can broadcast across the galaxy, we can break that path into a sequence of steps. Each step has some probability of being completed. The probability of getting all the way through depends on the probabilities of every individual step. The steps include things like the formation of the first self-replicating molecule, the transition from simple cells to complex cells with internal structure, what biologists call the emergence of eukaryotes, the development of multicellularity, the development of nervous systems, the emergence of intelligence sophisticated enough to build technology, and finally, the survival of that technological civilization long enough to colonize space, or at least to broadcast across it. The math says that, given the apparent emptiness of the galaxy, at least one of those steps has to be enormously improbable. Otherwise, we would have already encountered the civilizations that passed through them. Somewhere in that chain of steps, there's a filter, a bottleneck so narrow that almost no one gets through. The question Hansen asked, and the question that gives his essay its title, is, where in the chain is the filter? Is it behind us, or is it ahead of us? The hopeful version is that the filter is behind us. In this version, one of the steps that life has already completed on Earth is the impossibly hard one. Maybe the formation of the first self-replicating molecule was a 1 in a trillion accident. Maybe the transition to complex cells, which on Earth seems to have happened only once in 4 billion years, is a vanishing improbability. Maybe the emergence of intelligence is the bottleneck, and most worlds with bacteria never produce anything more. If the filter is behind us, then we are the rare survivors. The galaxy is empty because almost everything that ever started got stuck early. We made it through. The hard part is over. The future, while not guaranteed, is at least not constrained by the same brutal mathematics that has kept everyone else silent. This is the version of the great filter that astronomers find emotionally bearable. It says we are unusual, but not doomed. The silence is the sound of 1,000 failed starts. We are the one that did not fail. There is a particular candidate for which step might be the filter, and it is worth pausing on. The transition from simple cells, the kind without a nucleus, to complex cells, the kind that have internal compartments and can eventually form multicellular organisms, happened on Earth only once in 4 billion years. As far as biology can tell, every complex cell on this planet, in every plant and every animal and every fungus, descends from a single fusion event in the deep past, in which one kind of simple cell engulfed another, and the two of them, instead of one consuming the other, learned to live together. This event, the origin of what biologists call the eukaryotic cell, may be the rarest thing that has ever happened on Earth. It may be the bottleneck the entire galaxy has been failing. If that is the filter, then the galaxy may be full of bacteria, subsurface oceans on icy moons, tidally heated rocky worlds, deep aquifers on planets we have not yet imaged, all of them slowly stirring with simple life that has been going for billions of years and has never gotten any further. The galaxy may be alive, in some sense, almost everywhere, just not awake. And if that is the picture, then we are something close to miraculous. Not the only life, but the only life that thinks, the only life that asks, the only place in the galaxy where the universe has, briefly, become aware of itself. If the filter is behind us, we already won. And every answer to the silence makes the silence louder. But Hansen's essay does not stop there. The harder, sharper version of the argument is the one that comes next. And once you see it, it is hard to unsee. The dark version of the great filter is that the bottleneck is not behind us. It is ahead. The logic is unsettlingly simple. If we look at the chain of steps from non-life to galaxy-spanning civilization, and the galaxy is empty, then at least one step has to be near impossible. The question is which step, and the steps that have already happened on Earth are not, individually, all that impossible. We can study them. We can model them. None of them looks like a 1 in a trillion event when you examine the biology closely. The origin of life happened relatively quickly after the Earth cooled. Complex cells took longer, but they happened. Multicellularity has actually happened multiple independent times. Intelligence has emerged in many lineages, in different forms. None of those steps, when you really look at them, seems obviously impossible. But there's one step in the chain that we have not yet completed. The step from a young technological civilization that has just developed radio and nuclear weapons to a mature, long-lived, galaxy broadcasting civilization that has survived for tens of thousands or millions of years. That step, the step we're standing on right now, we have only been broadcasting for about 100 years. We have had the ability to destroy our own civilization for less than 80. We are reshaping our planet's atmosphere on a timescale that is geologically instantaneous. We have not yet survived the experiment of becoming a technological species. By any honest measure, we cannot say whether we will. And if the filter is ahead of us, this is exactly what the silence sounds like. The silence is not the sound of a galaxy where intelligence is rare. It is the sound of a galaxy where intelligence appears, develops technology, and then, with terrifying consistency, ends. Every civilization eventually, in some way, snuffs itself out, or is snuffed out. The window in which a civilization is loud, between developing radio and meeting whatever ends it, is narrow. Maybe a few hundred years, maybe a few thousand. Long enough to be brilliant, not long enough to be heard across the gulf between stars. If that is true, then every civilization that has ever lived died before it could speak. The mechanisms are not difficult to imagine. Nuclear war, engineered pathogens, runaway artificial intelligence, climate collapse, resource exhaustion, some technology we have not invented yet that turns out to be cheap, easy to make, and capable of ending the species that made it. There are many doors out of the loud era. There may not be many doors that lead through it. This is the version of the great filter that has kept some scientists, in private conversations, awake at night. Because if the filter is ahead, then the long silence we are measuring is not just data about the universe. It is data about us. It is a forecast. The astrophysicist Brian Cox once put it this way, and the framing has stayed with the field. Maybe the filter is the natural lifespan of any civilization that develops the technology to study itself. Maybe the moment we are in, the moment of being capable of asking where everybody is also the moment that is statistically most likely to be the last. There's a strange, almost mathematical loneliness in this version. It says that the silence is not the absence of intelligence. It is the residue of intelligence. The galaxy has been alive, in this picture, many times over. Civilizations have risen on 1,000 worlds, looked up at their own night skies, asked their own version of where everybody is, and then, in some way we cannot specify, ended. The silence is what is left when the questions stop being asked. And the strangest part of this thought, the part that is hardest to sit with, is that we may be following the same path right now. We may be in the loud era. The very fact that we are sitting here tonight, asking this question with curiosity rather than urgency, may be a sign that we are still inside the window, still on the side of the filter that has not yet closed. The radio noise we are leaking into space, the satellites in orbit over our heads, the conversations happening in millions of cities at this moment, all of it may be the kind of brief, brilliant, unsustainable activity that the galaxy has seen many times and never seen last. That is hard to write. It is hard to read. It does not need to be exaggerated. The math is what it is. And the answer that comes next is, in some ways, even harder. There is a category of proposed answer that does not get talked about much in the popular versions of the Fermi paradox, because it sits somewhere between science and science fiction. And the people who study these things seriously are careful about which side of that line they walk on. But the idea has been around since the 1960s, in different forms, and it has not gone away. It is sometimes called the berserker hypothesis, after a series of science fiction novels by Fred Saberhagen. The hypothesis goes like this. What if the galaxy is silent because something is making it silent? The argument starts from a simple observation about technology. If you can build self-replicating machines, machines that can find raw materials, refine them, and use them to build copies of themselves, then those machines, once released, will spread on their own. They do not need their builders. They do not need to be supervised. Given enough time and energy, a fleet of self-replicating probes could spread across an entire galaxy in a few million years, which is a blink of an eye on cosmic timescales. The math works out, even at sublight speeds. The galaxy, in principle, could be filled with such machines already. And here is the dark turn. What if some civilization somewhere, sometime in the deep past of the galaxy, built a fleet of probes whose purpose was not exploration but extermination? Self-replicating machines designed to detect any radio signal, any biosphere, any sign of emerging intelligence, and to terminate it. Once released, those machines would not need their builders. They would not need to be reauthorized. They would simply continue, indefinitely, doing what they were built to do. We have no evidence such things exist. To be clear, this is a hypothesis, and a speculative one. But the unsettling thing about the berserker idea is that it does not require multiple civilizations to agree to anything. It only requires one. Out of all the civilizations that may have ever existed in the 4-billion-year history of the galaxy, only one needs to have built such a system, and the system would still be running. And the consequences of that hypothesis, if you take it seriously, are immediate. It would mean that the silence is not absence. It is enforcement. It would mean that broadcasting into space is dangerous. That building a beacon to announce your presence is the same as standing in a forest at night and lighting a fire to attract whatever is out there. This is, in fact, an argument that some scientists have made in opposition to projects that have proposed actively beaming signals to nearby stars. The astronomer David Brin and the physicist Stephen Hawking, before his death, both expressed concerns about active broadcasting. Their argument was not that aliens definitely exist. Their argument was that we cannot rule out the possibility that something dangerous does, and that we are, by broadcasting, taking a risk on behalf of the entire species. The silence we are listening to may not be empty. It may be the careful silence of every civilization that learned to rule. The galaxy is not empty. It is patrolled. And there's one more answer. The one that takes this idea and makes it not a hypothesis about machines, but a hypothesis about everyone. In 2008, the Chinese science fiction author Liu Cixin published the second novel in his three-body problem trilogy, a book called The Dark Forest. The book is fiction. The hypothesis it proposed has, since then, become one of the most discussed answers to the Fermi paradox in serious astrobiological circles because it does not require any specific civilization, any specific technology, or any specific event. It only requires game theory. The argument, stripped of the novel's fictional framing, runs like this. Consider any civilization that emerges in the galaxy. That civilization has two basic facts about its situation. First, it cannot know the intentions of any other civilization. Second, the technological gap between any two civilizations of different ages is likely to be enormous. A civilization 1,000,000 years older than yours is not slightly more advanced. It is incomprehensibly more advanced. The relationship is like the relationship between you and a single-celled organism, except even greater. Now consider what those two facts mean together. You cannot know whether another civilization is friendly, and if it turns out to be hostile, the asymmetry of technology means you cannot defend yourself. The risk of being seen by anyone is therefore very high, and the cost of being seen by the wrong civilization is total. The rational response in such a situation is to be silent, not because you are hostile, not because you are afraid in some emotional sense, but because game theory, applied coldly to a galaxy in which any civilization could be hostile and any technological gap could be lethal, recommends silence as the dominant strategy. You listen. You do not broadcast. You hope no one notices you. And if you do see someone else, the same logic that recommended your own silence recommends that you assume they are dangerous and act accordingly. Liu Cixin called this the dark forest. The galaxy, he wrote, is a forest at night, and every civilization in it is a hunter creeping through the trees. Every hunter must assume that every other hunter is also a hunter, because the cost of being wrong is annihilation. The silence is not the silence of an empty forest. It is the silence of a forest full of hunters, all holding very still. This is, on its surface, a fictional construction, but the game-theoretic argument behind it is real, and it has been studied seriously by researchers who think about cosmic strategy. The conclusion is uncomfortable. If the dark forest logic is correct, then advanced civilizations have a powerful incentive to stay silent, and an even more powerful incentive to terminate any civilization that broadcasts before that civilization can become a threat. We have been broadcasting for 100 years. There's a quiet detail in this hypothesis that often goes unnoticed. The dark forest does not require a civilization to be evil. It does not require malice or aggression. It only requires the game theory to be correct. A perfectly peaceful civilization, applying perfectly rational reasoning to its survival, will reach the same conclusion. Stay quiet. If you see a stranger, do not assume the best. The forest is dark for a reason, and there is a second detail, which is harder. The logic of the dark forest does not just recommend silence. It recommends preemption, because if a civilization that broadcasts is risking annihilation, then a civilization that hears a broadcast has a difficult choice: to stay quiet and hope the broadcaster does not become a threat, or to act, while the technological gap still favors you, and remove the broadcaster from the forest. In the cold logic of the hypothesis, the second choice is the one that minimizes long-term risk. It is also the one that turns the forest from a place of careful silence into a place of quiet erasure. We have been broadcasting since roughly the 1920s. The radio waves from our earliest broadcasts have now traveled about 100 light-years from Earth. They have passed through the neighborhoods of thousands of stars. They have been, in principle, detectable by any sufficiently advanced civilization within that bubble. We have not yet had a response. The dark forest hypothesis suggests that the absence of response is not a sign that no one is there. It is a sign that the response, if it comes, will not be a hello. The first rule of the forest is do not be heard, and we have not yet learned the rule. Before we walk into the last and hardest answer, there's a piece of honest contestation that has to be included, because the field has been wrestling with it since 2018, and the conversation is not finished. It is the work of 3 researchers at the Future of Humanity Institute at Oxford: the philosopher Anders Sandberg, the engineer Eric Drexler, and the philosopher Toby Ord. Their paper is called Dissolving the Fermi Paradox. The argument is statistical, and it is careful. The Drake equation, they pointed out, returns large numbers when you plug in single-value estimates for each factor. But many of those factors are not single values. They are deeply uncertain. The probability that life arises on a habitable planet is not a number we can write down. It is a probability distribution that spans many orders of magnitude. Same for the probability of intelligence. Same for the probability of communicating civilization. Same for civilization longevity. What Sandberg, Drexler, and Ord did was redo the Drake equation honestly. Instead of plugging in single estimates, they put in proper uncertainty distributions for each factor. Then they computed the probability that we are alone in the observable universe. The result, given the genuine uncertainty in our knowledge, was that there is a substantial probability, somewhere around a third, that humans are alone in the observable universe entirely. Not alone in the galaxy, alone in the observable universe. This is, in some ways, the gentlest answer of all the proposed answers, because it does not require anything dramatic to be happening. No filters, no hunters, no quarantines. The silence is the silence we should have expected, statistically, given how little we know about the underlying probabilities. We are not alone because something is making us alone. We may simply be alone because that is what the math allows once you stop pretending to know things you do not know. The Sandberg-Drexler-Ord paper has been controversial in the field. Some researchers have argued that their priors were too pessimistic. Others have pointed out that even their result still leaves a substantial probability of other life elsewhere. The debate is genuinely open. There's no consensus answer. But the paper does something important. It reminds us that the paradox itself, the very feeling that the silence is strange, depends on assumptions we cannot fully justify. Maybe the galaxy is empty for boring reasons. Maybe nothing dramatic is going on. Maybe the silence is not telling us anything except that we underestimated how rare this might be. And here's the strange thing about that answer. It is the gentlest. It is the one that does not require dread. And yet, when you sit with it for long enough, it carries its own quiet weight. Because if we are alone in the observable universe, then everything that intelligence does, every poem, every theorem, every act of love or curiosity or kindness, exists nowhere else. The universe is full of stars and silent. We are full of voices and small. We may be alone for boring reasons. That should comfort us. It does not. And the last answer is the one that has been waiting underneath all the others. We come now to the last and hardest answer. The one that does not propose a mechanism, does not propose a filter, does not propose a hypothesis to test. The one that simply takes the data we have collected over 65 years of careful listening and reads it for what it is. The silence is the data. For most of the history of this question, the silence has been treated as a puzzle, something that demands explanation, something that has to be accounted for by some theory or other. The Drake equation says there should be civilizations, so why are we not hearing them? The hypothesis is that there must be a reason. There must be a filter. There must be a dark forest. There must be something. But there is another way to read the silence. A simpler way. And it is, in some ways, the most disturbing of all. What if the silence is not a puzzle? What if the silence is the answer? What if the universe really is, as far as our instruments can tell, mostly empty of voices that can reach us? Not because of any specific filter, not because of any specific danger, but because the actual statistical truth is that civilizations capable of being heard across interstellar distances are vanishingly rare. They appear briefly. They make some noise briefly. And then, by whatever combination of physical, biological, and historical accidents, they go quiet again. The galaxy has been alive, in this sense, many times. It is not alive now in any way we can detect. The voices have come and gone. We are listening to the universe in its quiet years. And we are next. The implication is hard to look at directly. If the silence is the data, then the most likely explanation for why we have not heard anyone is that there is, at this moment, almost no one to hear. And the most likely explanation for why there is almost no one is that civilizations like ours, which allowed for a brief window and then are not, have a characteristic lifespan, a short one. We have been broadcasting for about 100 years. The galaxy is roughly 13 billion years old. If civilizations last on average a few thousand years before they are no longer detectable, then at any given moment, the chance of two civilizations being loud at the same time and close enough to be heard is essentially zero. The silence is what a galaxy of civilizations sounds like when each civilization is loud for only an instant on cosmic time, and the instants almost never overlap. That is, mathematically, the explanation that requires the fewest assumptions. It does not require predators. It does not require a filter. It just requires that civilizations come and go quickly, on cosmic timescales, and almost never at the same time. And the implication, again, is hard to look at. We are loud now. We are unlikely to be loud forever. Whatever ends our window, whether it is something we do to ourselves or something the universe does to us, will likely come on the same timescales that have ended every other voice in the galaxy. There's a stillness in this thought that is different from the stillness of the other answers. The other answers all imply something. They imply a watcher, or a hunter, or a filter, or a bottleneck. They imply that the silence is doing something. The reading we are sitting with now does not imply anything. It just observes. The galaxy is a place where voices appear and disappear, briefly, on timescales we're not built to feel. Ours is one of those voices. The silence around us is not malicious or careful or watchful. It is simply the average state of a galaxy in which the average voice is brief. We are not being silenced. We are being averaged. The silence is not waiting for an answer. It is the answer. And every answer to the silence makes the silence louder. Take a breath. Let your shoulders drop. Notice, for a moment, the room you are in, the chair or the bed under you, the light, wherever it is coming from, the small sounds in the building, the hum of the refrigerator, The breath you just took. You are sitting inside a body that has been listening, in its own way, for its entire life. The cells in your retina are tuned to a narrow band of electromagnetic radiation, the kind of light a yellow star like our sun produces in abundance. The hairs in your inner ear are tuned to vibrations in air pressure, the same kind of vibrations that other animals on this planet use to communicate. Your skin is, in a real sense, an instrument. The entire body is a receiving station, evolved to pick up signals from the world around it. And right now, as you sit there, your body is being passed through by signals from across the cosmos. The cosmic microwave background, the residual heat of the Big Bang, is moving through you and through the room and through the planet at this moment. It has been moving through you your whole life. It will keep moving through you until you are gone, and through whatever is left of you afterward. You are made of atoms that have been listening their whole life. The carbon in your hands was forged in the heart of a star that died billions of years before our sun was born. The iron in your blood, the same iron that lets your blood carry oxygen, came from supernovae, from the violent deaths of giants. You are not separate from the silence we have been talking about tonight. You are part of it. You are made of the same matter that fills the empty galaxy, the same matter that sits in the spaces between every star. And so, in some quiet sense, the silence is also yours. The fact that the galaxy has not answered is not a fact about something far away. It is a fact about the place you are in, the room around you, the air over your face, the warmth of the blanket if you have one. All of it is sitting in the same silence we have been studying. We are not outside the paradox. We are inside it. That is, when you sit with it long enough. A strange comfort, not a happy comfort, a real one. The comfort of knowing where you are. It has been 75 years since Enrico Fermi sat down to lunch in New Mexico and asked, casually, where everybody was. He died 8 years later, in 1954, of stomach cancer at the age of 53. He never knew that his question would still be asked, in much the same form, 3/4 of a century later. He never knew that his name would attach to a paradox he raised over a meal. The men he asked the question to have all died. The cafeteria has been remodeled or torn down. The lab itself has changed mission and management several times. Everything around the moment has aged. The question has not. And the answers, as we have walked through tonight, have not made the silence smaller. They have made it bigger. Each proposed answer, taken seriously, opens up a door into a different and more difficult possibility. We are early. We are rare. We are watched. We have passed the filter. We have not passed the filter. We are being hunted. We are silent because everyone else has learned the rule. We are alone for boring statistical reasons. The silence is what civilizations sound like when they are brief. We are about to be brief. 8 answers. 8 different shapes of dread. None of them disprovable. None of them currently provable. All of them sitting on the same set of facts, which is that the most thorough search humans have ever conducted, across 1,300 nearby stars, 61 transiting candidates, and more than a decade of careful listening, has produced the deepest silence ever measured. The Fermi paradox is sometimes presented as a puzzle to be solved. Tonight, after walking through it, you may have a different sense. It may not be a puzzle at all. It may be, instead, a kind of mirror. The thing you see in the silence depends on what you are willing to bring to it. If you bring hope, you see the early universe, waiting for civilizations to grow up. If you bring caution, you see filters and forests. If you bring statistical humility, you see a quiet truth about our place in a very large, very old, mostly silent universe. What is undeniable is that the answer, whatever it turns out to be, will be the kind of answer that reshapes how we see ourselves. If we are early, we are the first chapter. If we are rare, we are precious. If we are watched, we are children. If we are next, we are a warning. The Fermi paradox is, in the end, a question about what kind of thing we are, and whether the silence we're sitting inside is something we are about to break, or something we are about to become. The question is older than anyone alive. The answer is older than that. Tonight we have walked slowly through one of the strangest and quietest questions in modern science. We started at a lunch table in 1950 with a casual 3-word question. We followed the math that says the galaxy should be loud. We listened, alongside Frank Drake in 1960, to the first careful search. We sat with the modern result, the deepest silence ever measured, after 65 years of listening. And then we walked through the 8 major proposed answers, the hopeful ones, that we are early, or that we have passed the hardest part, the sobering ones, that the conditions for civilizations are rare, or that the universe is genuinely empty for ordinary statistical reasons, the colder ones, the watchers, the patrolled galaxy, the silent forest of careful hunters, and the hardest one, the one that says the silence is not waiting to be explained. The silence is the explanation, and the explanation is that civilizations like ours are brief. None of these answers is settled. The field is genuinely open. There is no consensus. There may not be one for a very long time. The instruments will get better. The data will grow. New surveys will listen more sensitively to more stars, and the silence may eventually end, or it may deepen. We do not know, but we have walked the question tonight, end to end, the way it deserves to be walked. We have not flinched from the harder answers. We have not pretended the gentler ones are more likely than they are. We have sat with the question the way Fermi might have wanted us to, slowly, carefully, willing to look at every door it opens. And as we close, the paradox itself remains where we found it. Every answer to the silence makes the silence louder. That sentence has carried us through every solution tonight. It is the through line of this entire question. Every gentle answer, sat with for long enough, opens a darker version of itself. Every dark answer, sat with for long enough, has a quieter possibility behind it. The paradox does not resolve. It deepens. Every answer to the silence makes the silence louder. Tonight that is enough. If you have stayed with me this far, thank you. These are long, slow nights, and I am genuinely grateful to everyone who walks them with me. If subscribing makes sense for you, it really does help me keep making these, and there will be many more like this in the months ahead. We have only begun to walk through the strange, quiet questions that science has accumulated. For now, let yourself rest. Let the room go quiet. Let the silence we have been talking about tonight be a familiar thing, rather than a frightening one. Whatever the answer turns out to be, whatever the universe is or is not, you are here, in this body, in this room, on this strange planet that may be one of many or may be one of one. That fact alone is worth a quiet good night. Sleep well. The universe will still be quiet in the morning.